Electrical safety is paramount, especially when dealing with high-voltage systems. The reclosing of 12,000 volts distribution circuits introduces potential hazards, and understanding the associated risks is crucial. One of the best resources for electrical safety statistics is the Electrical Safety Foundation International, or ESFI. Their website, www.esfi.org, provides valuable information, data, and resources related to electrical safety. When considering reclosing on high-voltage lines, it's essential to understand the potential dangers. If a fault is temporary, like a tree branch momentarily contacting a line, reclosing can quickly restore power. However, if the fault is permanent, reclosing can exacerbate the problem, potentially leading to equipment damage, fire, or injury. Safety issues associated with reclosing are concerns for several reasons. Firstly, there is the risk of re-energizing a line that has a persistent fault. This could lead to a high current flow, causing equipment to fail or even explode. Secondly, there is the potential for creating a hazard for anyone working on or near the line. If the line is unexpectedly re-energized, it could result in severe electrical shock or electrocution. Thirdly, there is the risk of igniting fires. A fault can generate intense heat, which could ignite nearby flammable materials. The ESFI website offers various resources to help understand these risks. Look for safety data sheets, incident reports, and best practice guides. They may also have training materials and educational programs that can help inform workers and the public about electrical safety. When evaluating the safety of reclosing, consider the following factors. 1. The type of fault that is likely to occur on the circuit. 2. The speed of the reclosing operation. 3. The coordination of the reclosing relay with other protective devices on the system. 4. The training and experience of the personnel involved in operating and maintaining the system. Furthermore, the type of reclosing scheme used can affect safety. For example, a single-shot reclosing scheme will only attempt to reclose the circuit once, while a multi-shot scheme will attempt to reclose the circuit several times. A single-shot scheme is generally safer, as it reduces the risk of re-energizing a line with a permanent fault. Different types of faults can also affect safety. Temporary faults, such as those caused by lightning strikes or tree branches, are generally less dangerous than permanent faults, such as those caused by downed conductors. Reclosing into a permanent fault can cause significant damage and create a serious safety hazard. Therefore, it is crucial to have a system in place to detect and clear permanent faults before reclosing. The speed of the reclosing operation is also important. If the reclosing is too fast, it may not allow enough time for temporary faults to clear. This could lead to the reclosing into a fault, which could cause damage or injury. On the other hand, if the reclosing is too slow, it could cause a prolonged outage. The coordination of the reclosing relay with other protective devices on the system is also important. The reclosing relay should be coordinated with the other relays and fuses in the system to ensure that the fault is cleared quickly and safely. The training and experience of the personnel involved in operating and maintaining the system are also crucial. Personnel should be properly trained in the operation and maintenance of the reclosing system and should be aware of the potential hazards involved. They should also be able to recognize and respond to abnormal conditions. The ESFI website can provide resources for training and education. The website also publishes statistics on electrical injuries and fatalities. Reviewing this data can provide a better understanding of the risks associated with electrical work and help to identify areas where safety improvements are needed. The data often includes information on the types of injuries sustained, the causes of the injuries, and the occupations of the people who were injured. This information can be used to develop targeted safety programs and training materials. Besides ESFI, other resources are available. The Occupational Safety and Health Administration, or OSHA, has regulations related to electrical safety. The National Electrical Code, or NEC, provides standards for safe electrical installations. Professional organizations such as the Institute of Electrical and Electronics Engineers, or IEE, also offer guidance and resources. When analyzing electrical safety statistics, it's important to understand the limitations of the data. Statistics are often based on reported incidents, and not all incidents are reported. This means that the actual number of injuries and fatalities may be higher than the reported number. Additionally, statistics may not always provide a complete picture of the circumstances surrounding an incident. It is important to consider all available information when evaluating electrical safety risks. Reclosing relays are sophisticated devices that can be programmed with various settings to optimize their performance and safety. These settings include the reclosing time, the number of reclosing attempts, and the fault detection thresholds. Properly configuring these settings is essential for ensuring that the reclosing relay operates safely and effectively. The reclosing time is the amount of time that the relay waits before attempting to reclose the circuit. This time should be long enough to allow temporary faults to clear, but short enough to minimize the duration of the outage. The number of reclosing attempts is the number of times that the relay will attempt to reclose the circuit before giving up. This number should be limited to prevent repeated reclosing into a permanent fault. Fault detection thresholds are the levels of current and voltage that the relay uses to detect faults. These thresholds should be set carefully to ensure that the relay can detect faults quickly and accurately. Regular maintenance and testing of reclosing relays are essential for ensuring their continued safe and reliable operation. Maintenance should include visual inspections, cleaning, and lubrication of moving parts. Testing should include verifying the accuracy of the relay settings and the proper operation of the relay's protective functions. The NEC addresses reclosing in several sections. It's crucial to consult the latest edition of the NEC for specific requirements related to the installation, operation, and maintenance of reclosing devices. For example, the NEC may specify requirements for the overcurrent protection of reclosing circuits and the grounding of reclosing equipment. Understanding and adhering to these requirements is essential for ensuring electrical safety. In addition to the NEC, local codes and regulations may also apply. It is important to check with the local authorities to determine the specific requirements for electrical installations in your area. These local codes may be more stringent than the NEC in some cases. Implementing a comprehensive electrical safety program is essential for preventing injuries and fatalities. This program should include training, hazard assessments, safe work practices, and regular inspections. Training should cover topics such as electrical hazards, lockout-tagout procedures, and the proper use of personal protective equipment. Hazard assessment should be conducted to identify potential electrical hazards in the workplace. Safe work practices should be developed to minimize the risk of electrical accidents. Regular inspections should be conducted to ensure that electrical equipment is in good working order and that safe work practices are being followed. Reclosing on high-voltage distribution circuits is a complex issue with potential safety implications. Consulting resources like the SV website, adhering to the NEC and local codes, and implementing a comprehensive electrical safety program are essential steps in minimizing the risks. Additionally, consider conducting a thorough risk assessment specific to the reclosing operations to identify potential hazards and implement appropriate control measures. Risk assessment should consider factors such as the type of equipment being used, the working environment, and the training and experience of the personnel involved. The results of the risk assessment should be used to develop safe work procedures and to select appropriate personal protective equipment. Proper planning, training, and adherence to safety protocols are paramount when working with high-voltage systems. Always prioritize safety to protect yourself and others from electrical hazards. Remember to stay informed about the latest safety standards and best practices. Attend training courses and workshops to enhance your knowledge and skills. Share your knowledge with others to promote a culture of safety in the workplace. By working together, we can prevent electrical accidents and create a safer working environment for everyone. Furthermore, consider implementing a system for reporting and investigating electrical incidents. This system should allow employees to report incidents without fear of reprisal. All reported incidents should be thoroughly investigated to determine the root cause and to identify corrective actions. The results of the investigation should be shared with all employees to prevent similar incidents from occurring in the future. In addition to the technical aspects of electrical safety, it is also important to consider the human factors. Human factors are the psychological and physiological characteristics of people that can affect their performance. These factors can include fatigue, stress, complacency, and distractions. It is important to address these factors to minimize the risk of human error. For example, employers should ensure that employees are adequately rested and that they are not working under excessive stress. They should also provide employees with training on how to recognize and avoid complacency, and they should take steps to minimize distractions in the workplace. By addressing both the technical and human factors of electrical safety, we can create a safer working environment for everyone. Understanding the specific risks associated with reclosing on your system requires a detailed analysis of the circuit characteristics, fault history, and protection scheme. This analysis should be conducted by qualified engineers with expertise in power system protection and coordination. They can help you identify potential weaknesses in your system and recommend appropriate safety measures. These measures may include adjusting relay settings, upgrading equipment, or implementing new operating procedures. The ultimate goal is to ensure that the reclosing operation is performed safely and reliably, minimizing the risk of injury or damage. The Electrical Safety Foundation International website is a valuable resource. It can help you access relevant safety data sheets, incident reports, and training materials. By staying informed about the latest safety information, you can make informed decisions and implement effective safety measures. Regular review and updates of your safety program are essential to ensure its continued effectiveness. Changes in technology, regulations, and industry best practices can all impact electrical safety. Therefore, it is important to stay abreast of these changes and to update your safety program accordingly. This may involve revising training materials, updating procedures, or investing in new equipment. By continuously improving your safety program, you can minimize the risk of electrical accidents and create a safer working environment for your employees. Remember that electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents. By working together and prioritizing safety, we can create a workplace where everyone can work safely and productively. Continuous education and training are critical components of a robust electrical safety program. Ensure that all personnel involved in the operation and maintenance of electrical equipment receive regular training on electrical hazards, safe work practices, and the proper use of personal protective equipment. Training should be tailored to the specific tasks that personnel are performing and should be updated as needed to reflect changes in technology, regulations, and industry best practices. Consider using a variety of training methods such as classroom instruction, hands-on training, and online learning modules to cater to different learning styles and preferences. Regular refresher training should also be provided to reinforce key concepts and to keep personnel up to date on the latest safety information. By investing in continuous education and training, you can empower your employees to work safely and to prevent electrical accidents. A strong safety culture is essential for creating a safe working environment. A safety culture is a set of shared values, beliefs, and attitudes about safety that guide the behavior of individuals and organizations. A strong safety culture is characterized by a commitment to safety at all levels of the organization, from top management to front-line workers. In a strong safety culture, safety is not just a priority, it is a core value. Everyone understands that safety is everyone's responsibility and that it is never acceptable to compromise safety for the sake of productivity or cost savings. Building a strong safety culture requires a sustained effort over time. It involves communicating the importance of safety, providing training and resources, recognizing and rewarding safe behavior, and holding individuals accountable for their actions. By fostering a strong safety culture, you can create a workplace where everyone is committed to safety and where electrical accidents are prevented.